1 to 6.4 review for the mini test tomorrow. There are 3 formulas that we wrote on the board, and they're right up here in red. We have the classic exponential growth and decay formula. I think Mr. Heinlein wrote this one, and he used A and C. It doesn't really matter. We used P and P naught. But this value right there, this little C value, that's the initial value. And then 1 plus or minus the rate, minus if it's decay, plus if it's growth, and then time. And all of this is just like yearly growth. And then if we want to compound interest, we want to compound it monthly or daily or quarterly or semi-annually, then we have to get a daily rate and then the number of days. And so we need this N in there. And then if you read a story problem and it says continuously, compounded continuously, then we're going to use this bottom formula. Okay. Let's do over the graphs. You're absolutely going to have to graph. You're not going to have to graph the parent graph. You're just going to, given a problem like this, and I'm going to say graph. I'm going to give you an XY chart. I'm going to require 5 points. You're going to plot those 5 points. You're going to draw your curve. You're going to identify domain and range, and you are going to then use a dotted horizontal line to indicate the asymptote. So when you look at this one, we only plotted 3 on the review, but you should be able to plot 5. And again, for us, go ahead and go from the center. So for us, I would go 3, 4, and 5, and then 2 and 1. Again, this is that x minus 3 is a horizontal shift. 2 is the fact that it's going to be doubling, and then 3, in this particular case, is the initial value. So you can look at these graphs, but you for sure are going to have to graph. This one is going to go down because it's negative, and this has a vertical shift. This really doesn't have anything other than the base is E, and again, E is like 2.71. You are going to have your calculator do all these things. This is going down the -2. This half means it's decaying, and the -3 is a vertical shift down. Again, just be careful. The domain on all of them are negative infinity to infinity, or you can say all reals, which is what this symbol means. And the range is going to have restrictions. You're going to go from the asymptote up, or you're going to go from negative infinity all the way to the asymptote. And remember, you never actually touch the asymptote. You asymptotically approach that y value. And so you are going to use parentheses on your range. Okay. Again, this is just another graph. This is just some vertical shift. This is moving it left. It's E. It's still going to go here. That plus is still your asymptote. You are going to be given things whether it's growth or decay. This one is kind of a trick because it's 2x squared, where the x is actually not even in the exponent, which means it's not an exponential. It actually is just a quadratic. That's neither. There's growth. It's quadrupling. There's growth because it's going up by 50%. And this is decay because it's a negative exponent, because really you were multiplying by a 1/3, which is really decaying by 2/3. The y-intercept is always when x equals 0. The horizontal asymptote is always that little shift there. So again, the y-intercept is something you can always find by just plugging in x equals 0, which is true for all graphs. Simplifying here, right? Numbers with numbers, letters with letters, e's with e's. So 4 times 1 is just 4, and then e cubed times e to the 5th is e to the 8th. Remember, you're going to add these exponents because the exponent is keeping track of how many factors you have, and so you're adding them together. This whole thing gets cubed, so -4 cubed is -64. E to the 2x cubed is e to the 6x. Remember, a power to a power you are going to multiply. Here, the 4 just needs to chill. There's nothing it's going to go with. And then e to the 5x and e squared, you are just going to subtract. You can't subtract those, though. I mean, you can write it as 5x minus 2, but don't actually try to subtract them. That's actually totally fine. This is fine, and this is fine. Either of those answers is actually fine. 9 over 3 is 3, and then e to the 6x over e to the 4x, you would subtract and get e to the 2x, right? We play the cancel game. You can cancel a 4x from both of them. The cube root of 8 is 2, and the cube root of e to the 9x is e to the 3x. Remember, that's really the 1/3 power. So e to the 9x to the 1/3 is you are multiplying those, and you get that. And then we got all our story problems. Again, this is decreased by 15%, which is why you're going to see a 0.85 in there. Go ahead and round to the nearest hundredth since it's money. You're investing 5,000 for 2 years at 3% compounded monthly. So we have the monthly 12, we have the years is 2, we have the rate is 0.03. And then this says you want to have 5,000 in your account. So the 5,000 is here, and then you're trying to find C. And again, this is where you'd use your graphing calculator and go ahead and find that. You really don't even need too much of a graphing calculator. This is just a number, and then you just divide by it. The rabbit population is quadrupling every year, so we know that's a 4 in there. You start with 4 rabbits, how many you have after 5 years. So I don't really actually think we need to do any of this stuff over here. You just jump to this. We know that quadrupling, there's a factor of 4, and it's for 5 years, and you start with a 4. So you can just hop in right there. And now we have some of our compound interest. So we have quarterly, daily, and continuously. Remember, continuously, you're going to have the E. And then daily is 365, and then quarterly is 4 times a year, so it's 4. We're always just taking that 3,000. 5% is 0.05, and then for 2 years. This one I think we actually looked at in class. This is just a chart. If you look at this, if you look at the 0 value, that's going to tell you your A value, that 1/4. We know that's there, and if you look, it's going half, 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 right? It's always going down by a half, so you're just multiplying by a half every time, and so you get something like this. Now, if you had a graph, it's really the same thing. You know 0, 2, and you know 1, 6. So what's it doing? Well, it triples in 1 year, and it starts at 2. Boom, right? Tripling with a 3, and it started at 2 with the 2. Started at 1/4, and it went down by a half, right? All you have to do is decide what the initial value is, and then what the multiplying factor is. Okay, so this is we can plug this in our calculator. We did this one in class, but again, really, you can just take this first point 0, 20 and know that the A value is 20, and then it's doubling, so it's really, really close to 20 times 2 to the x. Now, if we used our calculator, we can actually do a linear regression and get the exact value. And that would be it. So you should be able to find the exponential equations from a table, from a graph. We have to be able to do all the story problems using the 3 different formulas. I'm not going to try to trick you on there. You have to be able to simplify with e's and numbers and x's and such. Those are really just our exponent rules from the last unit. And then we have to identify asymptotes, domains and range, whether it's growth and decay. And then we have to be able to graph them. And again, on the graph, on tomorrow's test, I'm going to give you an XY chart. I'm going to give you the equation. I'm going to give you an XY plane. I'm going to ask you to graph all 5 points. I'm going to ask you to label the asymptote, and I'm going to ask you to identify the domain and the range. And one thing that I actually didn't put on the test, I don't think on the graphs, is the y-intercept. But you should be able to do that. Remember, the y-intercept always corresponds to an x value of 0, and that's typically going to be in your XY chart anyway. So that is a point you are going to plot. Okay, hopefully this helps you out.